Hey everybody, it's Grace again, and today we're on lesson 4, and we're going to be covering operations. So let's get started. Okay, so we did cover operations a little bit in lesson 2, but I will review it once again. So in Java, the main operations we have are addition, subtraction, multiplication, division, modulo, and the parentheses. So the purpose of each is pretty self-explanatory. For the plus symbol is addition. Minus, we have subtraction. The asterisk for multiplication. Our / for division. The percent sign for modulo. And in case you don't remember, with the modulo operation, we need two numbers. So we could have something like 8 modulo 5. And what this would give us is the remainder if 8 was divided by 5. And so we should get 3. Another example would be 9 modulo 3. Okay, divide 9 by 3. That divides perfectly. So we actually have a remainder of 0. And so what this expression would give us is 0. And then finally, parentheses, self-explanatory. Now, the order of operations are parentheses, multiplication, division, modulo, addition, and subtraction. So, some cautions that I'm going to go over again. Firstly, you can only perform operations on values of the same type. So you cannot multiply an integer by a double or add a character and an integer, for instance. That would not work. You would get an error. Instead, you should be performing operations on the same type. So you can definitely add integers together, multiply them together, perform modulo on them, and so on. Another thing to watch out for is division. So try printing out 25 divided by 5. So let's go ahead and go to replit.com to do that. Once you've logged in, you should see this blue create button on the sidebar. Go ahead and press it. Make sure you use the Java template. And we're just going to title this lesson 4 and then create. Okay, so here, line 3, let's print out 25 divided by 5. And so the answer you should be expecting is 5. Now let's run this. Okay, our output is 5. That is expected, and it is correct. Now let's try printing out 8 divided by 3. Now, if you calculate this yourself, you would get like a fraction or a decimal, 2 2/3 or 2.66 and so on. But when we run this in Java, what does it give us? Okay, what we get instead is 2, just an integer, 2. We don't get a decimal or a fractional part. And why is this? This is because of integer division. When we divide integers in Java, it only returns the quotient. So in the case of 25 divided by 5, that divided perfectly, so we get 5. But 8 over 3, that didn't divide perfectly, so we only get the quotient 2. Now, if you want the result to be a decimal, at least one of the numbers needs to be a data type that stores decimals, which is a double. So we can easily fix this by typecasting. So in our example, 8 divided by 3, we can typecast the integer 8 to a double. And how we do that is we simply indicate double in parentheses before the number we want to typecast. So let's try that. All right, and now we get what we want, 2.666 and so on. Note that we do have a 5 at the end because it loses accuracy, as this is a repeating decimal. All right, now let's talk about while loops. So in the previous lesson, we already learned about the for loop, and the while loop can be used in the same way. So the syntax looks like this. First of all, you're going to initialize a variable. And this variable is what we use in our while loop. It's going to update, and it's what we're going to check against a condition. Okay, and then the second step, we have our while statement. So while, and then in parentheses, we have a condition according to the variable. So this could be comparison, for instance. Let's pretend I have a variable called counter. So I declare and initialize this outside the while statement. And I'm going to set it to 0. Okay, now for my condition, let's say my condition is counter less than 10. Okay, then we check if this condition is true. And then if it is true, we perform whatever code is in this statement. So let's say I just print out counter. And if this condition is not true, if it's false, then we do not execute this while loop. So I print counter. Okay, and then the third step, we update the variable. So here, I will just increment our counter. And you will notice that the while loop has the exact same components and steps as a for loop. It's just written in a different syntax. So we have initialization, the condition, and update. Now let us practice using and running a while loop. So together, let's write a while loop that prints out the numbers from 1 to n. And let's go to replit.com to do that. Okay, so first thing, let's create a variable called num. Now we wanted to print this loop to print out the numbers from 1 to n. So it would make sense to initialize it at the number 1. Okay, now let's write our while statement. Okay, we want num to go from 1 to n. So our condition, we should stop once num reaches n. So our condition should be while num is less than or equal to n. Inside the for loop, what we want to do is print out num. Okay, finally, we don't want num to be stuck at 1 forever, because if it does that, we'll always satisfy this condition and it'll keep running. So what we need to do is update num. And to do that, we simply increment it. Okay, then now let's also read in a value for n. And to do that, let's set up our scanner. And then the variable n, we will read in using the next int method. You can also add in a prompt. So what this program is going to do, first, it's going to ask you for a value for n, and then it's going to print out the numbers from 1 to n. So let's run this. Okay, for n, I will just go with 10. Okay, so we've printed out the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1 to 10, and our n is 10. So we have successfully created a while loop that prints out the numbers from 1 to n. And let's try this with a different n. Let me go with like a huge number like this. As you can see, it is a little slow, but it's pretty clear that's printing out the numbers one by one from 1 to n. And yep, I'm going to stop this now, else we'll be watching this the whole time. Okay, Now let's write a program that calculates the sum of the digits of a number. And we can actually use a while loop to help us with this. So let's go back to Replit. And I'm going to clear everything from lines 6 to 13. So the first thing we want to do is read in a number. So I'm just gonna create a variable called n and read in an integer value for it. Okay, now let's think about this. Pretend I have the number 1, 2, 3, 4, 5. No, that's a bit unclear. Okay, now I want to add the digits of this number. Now, logically, would you go from left to right or right to left? And let's think about this in terms of place values. So 5, this is a place value of 1. 4, we have a place value of 10. 3, this is the 100 place value. 2, 1,000, and 1 in the 10,000s. Well, logically, you probably want to go from the smaller place value to the greatest one, right? So then that means we want to be able to obtain each and every one of these digits starting from 5. So first 5, and then 4, and then 3, and then 2, and then 1, from right to left. Okay, now, so how can we do this? Using the operations we know, which are plus, minus, times, divide, and modulo. How would you obtain, for instance, this digit 5? Well, we can most likely rule out our addition and subtraction. Also, our multiplication, those are not going to be of use to us. So the operations we're going to be using actually are our division and modulo. So to obtain this digit 5, we would take 1, 2, 3, 4, 5 mod 10. Correct? Because if we did that, we would be, all this would divide, and then we'd be left with just 5, the ones digit. Okay, so this gives us 5. But then we want to obtain the next digit, 4. And how will we do that? We basically want the rightmost digit each time, but 4 is the second rightmost. So how we can fix that is we then divide 1, 2, 3, 4, 5 by 10. Now you're thinking, wait, this is integer division. I thought it creates errors or it might not be helpful. In this case, it actually is very helpful because it doesn't include a decimal part. We just get rid of this 5. And we're left with 1, 2, 3, 4. Now 4 is the rightmost digit. And we take this number mod 10 again, and then we divide by 10 and so on until what we're left with is simply 1. And this is our last digit. All right, now then how do we implement this? So what we should start with is creating a variable to store our current digit, which is always the rightmost digit in n. So I'm going to call this cur digit. And then I'm going to create another variable, digit sum, so we can print out our output. Okay, now remember that I said a while loop comes in handy. So what our condition here will be while n is greater than 0. And why is that? Let's take a look. So in our final loop, we're left with 1. Okay, then our next step would be dividing by 10. Now, if we divide by 10 in Java, we would get 0. Okay, and so then we repeat the process. We take 0 mod 10, and then we're dividing 0 by 10 again, which gives us 0. And we repeat the process, and we keep getting n equals 0. Then this means the loop never ends. So that's why we have to ensure that n is greater than 0. Okay, so then within the for loop, what we'll do first is get the current digit. And remember how we do that is n mod 10. Okay, then we need to update n. And to do that, we divide it by 10. Finally, our output asks for the sum of all the digits. So we need to update digit sum by adding the value of the current digit to it. And then finally, we can print out the digit sum. So using string concatenation, we have the digit sum is, and then a plus sign. We print out the value of digit sum. So let's run this and test it. So for n, I will enter the example I use, which is 1, 2, 3, 4, 5. The digit sum we should expect is 15. And there we go, our output is correct. The digit sum is 15. Let's try another number. I'll just go with a random number like this. The digit sum is 31, and you can quickly add it up yourself. 8 plus 3, 11, 21, 31. Yep, it's correct. All right, so now you've just learned how to use a while loop to calculate the sum of the digits of any number. And that's great. Now, let's write a program that calculates compound interest. And for anybody who doesn't know compound interest, I provided a formula below. You don't exactly need to know how it works. This is just a matter of using Java operations and implementing the math. So as you can see here, we have variables A, which is the final amount. P is the initial principal balance. So this is the initial amount that we want to perform compound interest on. And then R is our interest rate. This is just an integer number. N is the number of times interest is applied per time period. And T is the number of time periods elapsed. Okay, so this seems like a lot, but we can actually break this down pretty easily. So first things first, what we want in our input values will be P, R, N, and T. And then we're trying to calculate A, the final amount. And then what do we want to output? We want to output the compound interest. Now, compound interest is not A. It's actually A minus P. That's the interest part. So let's go to replit.com. And let's take the first step, which is reading in input. So we can print out prompts for each of these since it is going to get a bit confusing perhaps. So first, enter the principal amount. And we declare an integer value, P. Actually, we don't want an integer here. We're dealing with money. So we'll declare a double amount, P. And we will read it in using the next double method. And then we want to read in A, the interest amount. And here we're just going to let it be an integer. Now, of course, if you want, you can also let R, the interest rate, be a double. And then we read in N, the number of times compounded per time period. This is an integer value. And then we read in T, the number of time periods elapsed. Once again, this will be an integer value. All right, now, so let's declare a variable A, and this is going to be a double, since A will be a decimal, because we're working with money. And let's start it off at P, the principal amount. Okay, so our rate, in our formula, we actually have something a bit complex here in the parentheses, 1 plus R over N. So let's try simplifying this. We let R equals what's in the parentheses instead. So 1 plus R over 100. And here, you're going to want to be very careful. We're doing R over 100 because we're working with percentage, which will end up as a decimal. However, here we have two integers, so we need to typecast one of them. I'm just going to typecast 100 and indicate that it's a double with a D at the end. And divide by N. So this is exactly what our formula shows. And you know what? I'm going to change R to a double as well. Okay, there we go. Now, what's in the parentheses here is to the power of N times T. So this is the same thing as multiplying what's in the parentheses by itself, N times T times. And we can use a for loop to do this. So we want this to run N times T times. And each time we want to multiply T by what's in the parentheses. Now here I'm going to multiply A by our rate because this is our final amount that we're looking for. Now, finally, we want to calculate the compound interest. And as you may recall, the compound interest is A minus P. So we're not quite done yet. We've calculated A successfully. We just need to calculate the compound interest. So I will call it CI, compound interest for short, and that equals A minus P. Now, these two values are completely different now. A is actually greater than P. It's no longer equal to P. And finally, we can print out the total value, or let's say the final amount to be more clear. We print out the final amount first, which is simply A. And then we print out the compound interest, which is our variable CI. Okay, wow, that was pretty long, but we managed to do it. So now let's run it and test it. Okay, so we have our prompt, enter the principal amount. And I will go with 5,000. Our interest rate, let's say 5. The number of times compounded per time period. Let's say we're compounding annually. So this will be 1 time. And the number of time periods, 3. So for our final amount, we get 5,788.125. And for a compound interest, we get 788.125. And we can verify this using a compound interest calculator online. Okay, our initial investment was 5,000. The length of time in years, we said 3. Estimated interest rate, 5. The compound frequency was annually. Okay, so we calculated. And there we go. In 3 years, you will have 5,788.13, which is correct. Here we are actually at the 1,000th place, but if we round it to the hundredths, we should get 13. And then we can simply subtract the principal amount, which was 5,000, to get our compound interest, which was simply 788.13. In this case, thousandths, but once again, round to the hundredths, and you get 0.13. Okay, so we got this to work successfully. Great job. Now, let's briefly recap. So in this lesson, we covered operations and while loops, and we also used them both to calculate the sum of the digits in a number and to calculate compound interest. Thank you guys so much for watching this lesson, and I will see you next time. Bye.